Hello everyone, I'm Dr. Jyoti Mandala. I welcome you all to the video lecture series on the course Operating Systems. We are learning about different types of scheduling algorithms. As part of that, we have learned like scheduling algorithms are divided into two types, preemptive and non-preemptive. And we are learning about different non-preemptive scheduling algorithms. Under that, we have already learned about FCFS and SGF algorithms. I hope you all are clear with those two algorithms. In this lecture, let us understand what is priority scheduling algorithm. So priority, I'm telling once again, priority scheduling algorithm is of two categories, non-preemptive and preemptive. In this lecture, we are going to understand about priority non-preemptive scheduling algorithm. So what is actually this priority non-preemptive scheduling algorithm is, whenever a list of processes are requesting for the CPU, then for each process, a priority will be assigned. Okay, and whichever process will be having the highest priority, that will be given the chance to be executed by the CPU. Okay, now the lower the value, the higher the priority is. It's like ranking only. So the rank one will be having the highest priority, and then rank two, and then rank three, like that. So whenever the process comes into the ready queue, a priority should also be connected to that, so that the highest priority process will be given a chance to be executed by the CPU. So this is very simple. So completely basing on the priority, the processes will be executed. Because it is non-preemptive scheduling algorithm, what we are considering, once a process has been selected by the CPU, then until and unless it finishes its execution, it cannot be releasing the CPU. Right? With this background, let us understand one example. So I'll take one example. You see here we have five processes, process 1 to process 5. Okay, so these five processes, if you see this diagram, these five processes, they have considered the priority, they have given the priority. We will be providing the burst time, and also we will need to provide the arrival time. So burst time talks about the amount of time required to finish, like amount of CPU time required by each process to finish its execution. You can see from this table, process P1 and process P3 both are having the same priority. So that is also okay. Only information we need is what is the priority of each process, what is the burst time, and what is the arrival time. Now let us understand how can we solve this problem. So we are analyzing our algorithm using two parameters. That is what we have done for FCFS and SGF. We have considered the waiting time and we have considered the turnaround time. So let us understand how to calculate that one. So for calculating that one, we need to draw the Gantt chart, right? So what I'll do here, consider we have started at the time interval 0. So at time arrival interval 0, you can see here we have got two processes, P1 and P2. So in the Gantt chart, which one has to start? Because P1 and P2 both has arrived at the same time. Now considers the priority. So we need to consider the priority. If you see P1 and P2, which one is having the highest priority? You can see from P1 and P2, P1 is having priority 1 and P2 is having priority 2. So as I already told you, the higher the value, it is like a rank. So P1 is having the highest priority. So the lower the value, the higher the priority. So we will be considering P1 to start its execution. So P1 will be assigned to CPU. So it will be executed. You can see in the diagram here in the table, it requires 4 seconds. So 1 second, 2 second, 3 second, 4 seconds it will be executed. Understand, we are talking about non-preemptive. So it has to complete its execution. So while we are executing, you need to check always, whenever for each second you are executing, you need to check the arrival time also parallelly. Got it? So you can see from 0, 1, 2, 3, 4, no process has been arrived. So P1 has completed its execution. At T, you can see here at time 4 seconds, P1 has finished its processing. No processor is assigned to P2 now. So processor is now assigned to P2. Why? Because already in the ready queue, you can see this is the ready queue. Okay. In the ready queue, already P1 is there. We have done the P1 and the only process that is available here is P2. So we can start executing P2 now. At 5th second, nothing has arrived. Okay. And at 6th second, you can see we have got a new process called P3 that has to be added to the ready queue. All right. Now P2 should continue its execution. Why? Because it is a non-preemptive scheduling algorithm. Already it has executed. Out of 3, it requires 1 more second it has to execute. So it will execute 1 more second, and then P2 has completed its execution. You can see here. Now only process that is available in our ready queue is P3 is only available in our ready queue. So that has to be executed. So that will be executed for 1 second. And you need to check, always remember, at each time in timer, we need to check the arrival time. That is what important. So at 8th second, nothing is there. So P3 will continue its execution. At 9th second, nothing is there. And you need to keep a track like P3 requires how many seconds? 7 seconds, out of which we have executed only 2 seconds. So 3 more seconds has been executed. At 10th second, nothing has arrived. At 11th second, you can see we have got P4. So that has been added to the ready queue. Okay, still P3 will continue 1 more second. So at 12th second, you can see here we have got P5 that also will be added into the ready queue. And then P3 will continue. You can see P3 has completed all its 7 seconds of time. So P3 has completed its execution. We will stop here. So from 7 to 7 seconds, it requires 14 seconds. It has completed its execution. Now comes a question like between P4 and P5, which process has to be selected? Isn't it or not? Because we have two processes now. Now we need to check the priority. If you see P4 and P5, what is the priority? P4 is having the priority of 3 and P5 is having the priority of 2. So we will be selecting P5. Why? Because this is having the lowest value. So the lower the value, the highest the priority is. So P5 will start its execution, which requires 2 seconds of time. So 2 seconds it will execute, and the only process that is left is P4. So P4 will start its execution, which requires 4 seconds. So for 4 seconds, it will execute. So this is how non-preemptive priority scheduling algorithm will work. Purely it depends on the priority. Always remember lower value, highest priority. Right? And if two processes are arriving at the same time, then we will see the priority. And if only one process is there in the ready queue, that will be taken directly. And once the CPU is allotted, until and unless it's completed its execution, it will not be releasing the CPU. Right? So with this information, now let us calculate the waiting time and turnaround time. You can see how waiting time is calculated. We already know the formula is start time minus arrival time. So for P1, you can see start time is 0 and arrival time is also 0. So 0 minus 0 is 0. For P2, you can see start time is 4 seconds and arrival time is 0. So 4 minus 0 is 4. For P3, 7 minus 6, 1. For P4, 14, sorry, P4 is this one, 14, 16 minus 11. And for P5, 14 minus 12. All right. So with these values, we need to calculate the average now, and the average will be 2.5. Now, how the turnaround time will be calculated? Turnaround time formula is completion time minus arrival time. So you can see here, how can we calculate the completion time? For P1, you can see P1 completion time is 4 seconds. So 4 minus 0. So you got 4. You can see P2 completion time is 7. 7 minus 0 is 7. P3 completion time is 14 minus 6. Okay, that is what we have done here. P4 completion time is 20 minus 11. So that is what we have done. P5 completion time is 16 minus 12. That is what is done here. Right? So the total average turnaround time is total of all these values by total number of processes, which we got 6.7. Right? So this is how non-preemptive priority scheduling algorithm will work. Okay, I hope you all are clear with this algorithm, how it will be executing the thing. But there is a drawback for this process. What is the drawback is, it is called as starvation. What do you mean by starvation is, if you see here, if a new process come, let us consider one approach. Let us consider in your ready queue, you already have some processes P1, P2, and they are already in the ready queue, and a new process has been added, which is P5. Okay. Now, if P5 rank is 1 and this rank is 3, 2, then P5 will be given a chance to be executed by the CPU. Isn't it or not? So this will be given a chance to be executed by the CPU. But later, after some time, let us consider P4 again got a chance, one more process has been added to the ready queue. In that case, what happens? That process, if its priority is again 1, then that will be again given a chance. So in this scenario, if you see, always we are giving chance to the same process. What is that process? Always we are giving chance to the same process, but these two processes are keep on waiting because of their lowest priority. That means if any highest priority process comes to a ready queue, the lowest priority process will be keep on waiting. So this problem is called as starvation. That means they will be keeping on waiting. The lowest priority algorithm, sorry, not algorithm, the lowest priority processor keep on waiting. So this problem can be solved by using your aging technique. What do you mean by aging is, suppose if you what we need to do, let us consider this process for 10 minutes. After 10 minutes of time, the priority of each process has to be reduced. So this rank becomes 2, this rank becomes 1. So if you do like this, then P2 and P5 will be having both the rank first rank only. In that case, what we will consider FCFS algorithm, and P2 will get a chance to be executed. That means we are increasing the age. That means we are increasing the priority of the process after certain time. Okay, so that is how we are solving this starvation. So this is all about this priority scheduling algorithm. I hope you all are clear with this lecture. So for your practice here, I am displaying one assignment. Just make a note of this one and try to solve, like try to calculate the average waiting time and try to calculate average turnaround time. I hope you all are clear with today's lecture. Let us all meet in the next lecture. Until then, thank you all of you.